All right, hello students. We are going to get ready to do this investigation. Find it in the Chemical Reactions Unit 4 folder, and it is called What's What, and it's to help you learn more about physical and chemical properties. So you can open this up just like what I'm doing. And as I do the investigation, I will give you the data that you need to fill in this document and complete this document. Okay, this top table here, let's just hold off and you can answer the definitions and insert Google Images or draw to go with the definition. You can do that at the end. Let's go ahead and start with the density station. So this investigation has 3 stations: a density station, solubility station, and flammability station. Okay, and hopefully by the end of this, you will get a better idea of how physical and chemical properties can be used to classify substances. So let's start off with density. All right, here we go. So it says measure the mass of the 25 milliliter graduated cylinder. So I'm gonna do that now. Here's a 25 milliliter cylinder. All right, and when using this, you always wanna make sure that it starts off at 0, and we are measuring in grams today. So go ahead and write down in this column, write down. Okay, so let's just call it 16 because it's fluctuating just a bit. So you can do 16, and you'll write 16 in each one of these cells. All right, and then it says measure 25 milliliters of laundry soap in the small 25 milliliter cylinder. So I want to fill it up to this mark right here. So here we go. Oh, that came out a little bit faster than what I thought. Okay, and you can see here we're at the 25 mark. So we'll put it on the scale and weigh it again. So we have 41.8. So for laundry soap, 41.8. Okay, and we'll put this to the side. And we'll go ahead and do the next one with rubbing alcohol, 25 milliliters. Okay, and there we go, 25. 37, so go ahead and write down 37 right here for alcohol. And then the corn syrup. Now this is extremely thick stuff, so I'm going to do my best here to pour it. All right, it's slowly making its way. Very thick. This liquid has a very high viscosity, meaning very high thickness, which might contribute to it having a high density. We'll see. We'll see how the density of this liquid compares with the other two, which I don't think I mentioned that, but if you read further down, you will see that the reason why we're collecting the volume and the mass of this is because we will be calculating the density. So there's a little bit on the sides. I'm not going to try to pour that back. I'm going to call it good. Because if I tried to pour it back, I think it would take forever. So we're at 51.8 grams. So you can put down right here, 51.8 grams. Okay, so that's all the information you need. Mass of the liquid, you will get that by subtracting these two values. So the volume is 25 because we put 25 milliliters in each graduated cylinder. And the density will be the one where you go down to this formula And once you've calculated the mass of the liquid by subtracting these two values, once you have the mass, once you have the volume, that's 25, remember, you do mass divided by volume, and that will give you the density, okay? And then something that's really, really cool, I'm gonna do it right now so you can see how density works with fluids, is I'm going to actually pour these in so you can actually see the layers. Even though they're liquid, they will not mix because they have very different densities. And you can see I'm trying to pour out the corn syrup, but it is so thick. This particular brand of corn syrup is even thicker than normal. So I don't think I'll wait the entire time for it to drain out. We're just gonna get enough in here so that you can observe it in its layer with the other two fluids. Okay, so you can see there, I was able to dump out just a little bit of the corn syrup, not the full 25 milliliters, but enough that we'll be able to see the layer, clear to defined line there. So next I'm going to dump out the laundry soap. So because the laundry soap has a lower density than the corn syrup, you'll see a very defined line between the two fluids. Okay, and then after that, the rubbing alcohol. Okay, so we can observe the physical property of density with these two fluids. The corn syrup is right here at the very bottom because it is the highest density. The laundry soap or dish detergent is in the middle, and then the rubbing alcohol is at the top with the lowest density. Now because they have different densities, you can see lines separating each fluid from the other fluid. Okay, and you could mix this, like I could turn it upside down, shake it, and these would eventually, given enough time, separate back out to where you see them now. Okay, all right, let's move on to the next station. So we'll do the flammability station. So go down to the bottom of your document, and yeah, let's do this one together, and based on your observations from what you see, you'll be able to answer the questions and write a description of what you notice, what you see. All right, so here we go. All right, so let's start off with the water first. We will dip the paper in water and then hold the wet paper over the flame for 4 seconds. Here we go. 1, 2, 3, 4. So you can see some black ash or soot that accumulated from the candle onto the paper, but the paper itself is not catching on fire. So yeah, paper by itself is definitely flammable, but when you soak it in water, because water is not flammable, it keeps the paper from lighting on fire. So let's try the strip dipped in alcohol. Here's the rubbing alcohol. All right, and we'll put it in the flame. And right away, you can see instant flammability. So paper is flammable, rubbing alcohol is even more flammable than paper, and that's why you saw the instant flame. And this, interesting, this has never happened to me, but it actually burned all of the rubbing alcohol off of the paper without burning the paper. That's crazy. I think if I would have held it in the air the paper would have caught fire, but because I dropped it in the pan, it kind of extinguished itself. So yeah, that's the flammability station. You can pause the video and answer the questions in your document. And now we're going to the solubility station. Okay. So with the solubility station, we have some powdered drink mix, and we have a couple cups here. This cup I will put 25 milliliters of water, and this second cup I'll put 25 milliliters of corn syrup. All right, so let's start out with the water, and I'll put 1 scoop of the powdered drink mix in the water and stir. Okay, so you can see the powdered drink mix is at the bottom of the cup. And once I stir it, let's see what happens. Let's see if you can still see all the granules and particles after I stir. Okay, so you can see all the sugar granules and flavor particles have dissolved. You can no longer see them. Okay, so the drink mix is soluble in the water. Let's try the corn syrup. Okay, so 1 scoop of drink mix in the corn syrup. You can see the granules and powder just sitting on top of the corn syrup. And let me try to stir it in. And yeah, as you can see, I could sit here and stir all day. The granules are not dissolving. They're just sitting suspended in the corn syrup. Get a close-up view of it here on the spoon. Yeah, you can see the granules still in that corn syrup, not dissolving. So the drink mix is not soluble in corn syrup. Okay, so that's the solubility test. All right, so after these 3 stations, you can see that we've looked at the physical properties of solubility and density, and we've looked at the chemical property of flammability. So you should have enough, or you will have enough information after this to answer all your questions and get this document finished. So go ahead and do that, and if you have any additional questions, feel free to email me.